So, hi guys, thank you for coming. My name is M.Fusco and I'm the project lead of Drools, the rule engine of Red Hat.
And my name is M.Swiderski, I'm jBPM project lead.
Okay, so what we are to talk about, what is our agenda. So as we said, we are the project lead of Drools and jBPM. So I don't know if how many of you knows what a rule engine is or a process management engine is. So we will give just a quick introduction about our project, but they are mainly this is mainly to give you a context of the central part of the talk, because in the central part of the talk we want to speak about GraalVM, what it is, why it's good, how it allows native compilation, and Quarkus that is built, well, not on top of it, meaning that you can use Quarkus without GraalVM, but it's nice when you can use them together, because you can have REST web service with a lot of technology that you are normally used to use in the Java environment, but also in native mode. So in order to make our project to be compatible with these technologies, we need to change them quite a lot, the internals. And so the central part of the talk is mainly about this journey. So what we had to do to our well-established and quite old Java project to make them compatible with these technologies. So as I said, I'm the project lead of Drools. Drools is the rule engine of Red Hat. So what is a rule engine? Is an engine that you program with rules. So it's not the imperative programming as you are used to do with, I don't know, Java or C or Scala or whatever, but it's more declarative. So you declare a rule. A rule is made mainly of two parts. The pattern matching part is the part when you decide which fact, which event, which data triggers the rule, and then you have the second part of the rule when you say what you do when the rule is triggered. And why you may want to use these technologies, because normally this is how business people reason, how business people think about their problem. They reason in rules. And the rules are pervasive in all business, going, I don't know, from the marketing, travel agency, but also the medical sector. One of the biggest installation we have is for instance in the Rochester center in Minnesota, when they do medical research for cancer, and they have this big rule set when the expert of the domain, in that case the oncologist, the doctor, decided how to classify a cancer. So and I could give you the similar example in all other sector, for instance in insurance company or a bank that has its own internal rules to decide if they want to give you a mortgage or not. And the other thing is that by doing this, you write the business rule in a language that is close to the business understanding. And the other good thing is that you have a clear separation between your business domain, your business, the business part of your program, and the infrastructural part of your program. And why you want to do that? Also because if you think about it, they have usually a very different life cycle. Probably if you are writing rules for the marketing of an online travel agency, you know that the rules are changing every minute. But the infrastructural, the architectural part of your code is not changing that much. So having this separation is also good for your architecture. So as I said, a rule is made of two parts. There is this left part, the first part, when you do pattern matching, basically when you select object from the working memory, from the set of objects on which the engine is reasoning, and then you have the left part when you take some action, okay? And the reason why I'm underlining these two things is, again, in the context of what we had to do to make this compatible with Graal. I will just to let you notice something. If you see in the first part of the rule, what we call the left-hand side, we have this constraint that has to be evaluated against the rule, and there we used a lot of reflection to do this. So if we have the Sprinkler object and via reflection we access to the on properties and check if it's true or false and do something about this, okay? And the second part is instead the part where we take the action, and what we did to implement this part is that we did some translation of that code in pure Java code, and we put that code into a static method of a class, and we loaded that class with dynamic class loading. So these are the two parts that we basically had to change: the use of reflection and the use of dynamic class loading, because they are not compatible with Graal.
All right, and the other part of the story is the jBPM, which is the business automation or the process automation in general. So that originates from a need for building up the business logic as a workflow, as a flowchart, which could include not only the flowchart itself, but can be structured in executing to the business rules as well. So the processes themselves can be actually defined in a structured process or unstructured. So it could be a simple from start to end defined from completely, or it could have a set of process fragments that allows you to do the execution ad hoc. jBPM itself provides a support for different standards to define your processes. So it's the main one, the BPMN2 specification, but it allows you to define your cases as well with CMMN and take advantage of the business rules and decisions based on DMN and DRLs. So the process itself could look at as simple as that. So you can have a set of nodes that you need to traverse to reach a certain business goal. And it could be, as I mentioned, that it is structured as this case, but it could be a completely unstructured. Individual nodes can be floating around and can be executed ad hoc at any time and as many times as needed. So that leads us to a quick introduction of what the jBPM and Drools is, and as we used to call them, the mature part of our daily work. And now we want to introduce something that is actually the main topic of this session, so the project called Kogito. And first things first, the name, which is almost the most difficult. So it's Kogito, it's not Kogito, it's not Kogito, or anything other variations, it's just Kogito. And it originates from the Latin quote, cogito ergo sum, I think, therefore I am. And we wanted to bring that into our domain, so the business automation domain. So we came up with the cogito ergo automate, meaning I think, therefore I automate. And that brings in the old or mature projects like Drools and jBPM into a completely different world. So we wanted to bring this into a cloud to make sure that we are not just running on the cloud, but we actually can embrace the power of the cloud infrastructure that allows us to run at scale and be much lighter and then smaller than we used to be when running on premise. So first and foremost, we want to bring the definition of the processes or rules or decisions into the running service. So it's like you don't have to spend much time besides defining your domain and then the business logic that is behind the domain, and that should be exposed as a service. So this is what we call it knowledge as a service. So directly from the process definition or from the decision definition or the set of rules, we can take this up and run this completely as a service without any manual coding from your end. This is far from the concepts of being low code, no code, because this is not about that. It's still a kind of development activity, but you still need to better understand your domain before you start building your processes or rules, rather than the other way around, where you just create a process and then try to figure out how to plug it into your domain to make sure that it actually makes any sense. So we have now a first demo coming on. So we have an onboarding service that, or onboarding application, we can call it, that consists of 3 services. One is the onboarding itself, so this is the entry point. This is a process-driven service, so we have the process definition behind it that tells you what it actually needs to be done to achieve an onboarding successfully. Then we have 2 other services that are driven by decision and rules. So payroll, it just consists of things that need to figure out how to set up the payroll information for the particular employee. And the HR is another set of business rules that drives the HR-related decisions. Yeah, so this is pretty much the onboarding process itself. So again, rather simple. So we have the first validation of employees. So this is performing a service invocation to invoke the information on the HR service to verify if the particular employee needs to be onboarded or is already there. And then going through a different set of activities to perform additional setup. And the setup payroll and setup HR is so-called process composition. So it delegates to another process definitions that are performing these individual tasks. So we wanted to now take this to show how it actually works with Kogito to make sure that we can show it quickly on what we've done to actually make it. Is it readable? Should be. So yeah, we're starting all those 3 services. These are the native image.
So I'm starting. I generated the native image through Quarkus and GraalVM, the native image of our services, and the very good thing that you can notice as in the beginning is that this service took just 7 milliseconds to come up. So this is one of the great advantages of using this technology. So this one took 6 milliseconds, and I'm bringing up these 3 web services that will talk to each other to do this onboarding process. Okay?
Yeah, and worth to mention that these are actually written in Java. So we have everything behind that is purely Java related. So we have the BPMN definition files, DRLs, the decisions for DMNs. This is all read by Java programs, exposed as you can see, a bunch of extensional features, as they call it here. So we have the CDI, we have Kogito, we have the REST Easy, and JSON marshalling. This is all done with Java frameworks that you most likely, if you're a Java developer, you most likely use.
And the other good thing, except for the quick startup time, is also the memory occupation. So for instance, we can check, you see this, the HR web service is taking 22 megs of memory. And normally, if you don't use the native image, you will easily go up to 100 or more megs.
Yeah, that's the complete memory usage, not just the heap.
Yes, exactly. Okay. So yeah, just to give you an idea of how this works, I'm doing the onboarding of these guys to my company, and so I send this JSON to the onboarding REST service, and I receive back a response where the onboarding process has been performed, meaning that this guy has now accompanied this, and it has been assigned with a manager, and
it has department manager. You can find the payroll information as well. So
exactly.
All 3 services have been invoked, and the different results have been come up. So if we run the same request again, we will get an information. You can then get information that the guy has already been onboarded, and you don't have much of the information that the services actually produce.
And if I change the ID, it means that I'm onboarding a new employee, and then the onboarding process will happen again. Okay, so this is our very first demo, and it shows the powerful of the environment and why we did this translation, this rewriting of our software to make it compatible with this technology. So this is mainly the why. Now the other interesting part is also the how. So what we are speaking about. First of all, we are speaking about of GraalVM. I don't know how many of you knows this technology, have heard about it. Just a few, okay. So this is a new virtual machine mainly created by Oracle. We are doing, Red Hat is doing small contribution to this, but it's mainly an Oracle project. And this thing is powerful because it allows you to have in a one single virtual machine not only Java code or Scala code or in general code that compiles to bytecode, but also to integrate with other languages, even dynamic languages, and to integrate as they were one single thing, meaning that I don't know, you are in Java with when the hotspot optimize your code, it does code inlining, for instance, meaning that if you have a small method that is called lots of time from the caller, at some point the body of the method it's inlined in the caller, so it doesn't have to call it anymore. It does to have to add another stack frame. Okay, the just-in-time compiler does this sort of optimization, but the GraalVM is able to do the same optimization also cross languages, meaning that if that method is actually a JavaScript or a C method, it will be inlined as well, okay? So it is able to do this optimization in a cross-language way, which is really interesting. The other very interesting part, which is actually the part that interested us the most, is the fact that one of the components of Graal, which is this substrate VM, is the component that allows you to create a native image of your Java program. Okay, so you just send your program to this compiler, and it creates an executable, a native image, which are the things that I run in my demo. That has this the advantage of having a very fast startup time and very small memory occupation, as you saw. Okay, so how does GraalVM work? GraalVM is based on the principle of the it does what is called the ahead of time compilation, meaning that I guess you know how the just-in-time compiler of Java works. When your Java program is running, hotspot kicks in, and all those optimization, like the as I said, the code inlining, the branch prediction, and many other optimization. GraalVM does the same, but it doesn't do it at runtime while you're programming learning, but does it at compile time, ahead of time, okay? And in order to be able to do this, it needs to, your program needs to comply to what is called the closed word assumption. What does closed word? And this gives you all the advantage, as I said, like the fast process startup and less memory occupation. But what does closed word assumption mean? Mean that it has to know upfront everything that is happening in your program. And if you do a reflection, it's impossible for the compiler to do this. If you do dynamic class loader, it's even worse, okay? So if you use a dynamic class loader and reflection, you are basically breaking the closed word assumption, meaning that GraalVM is not able anymore to know at compile time what's going on in your program, and it's not able anymore to create this native image, okay? And as I said, we used this technology a lot, for instance, inside Drools, because we did dynamic class loader loading to create the right part of the rule, the part of the rule that gets executed. So we actually loaded the class into our internal class loader, the class that executed the right part of the rule with this technique. and this is not supported at all in GraalVM, as I said. There are other stuff that is also not supported. You cannot have Java agent. JMX is not supported, and since you cannot have Java agent, there are other technologies that you probably are used to use, like JRebel or Byteman. They can all not work. And the other thing is, as I said, is reflection. In reality, with reflection, you can do something. I mean, Graal needs to know upfront where you should use reflection. But if you need to use reflection, you should tell Graal on which classes you want to use reflection. Okay, so in reality, you can do this, meaning that you can provide to the Graal compiler a JSON descriptor in which you say, okay, I need reflection on this class, on this class, on this other class. In this way, you are not breaking the closed world assumption, because Graal knows at compile time that he needs to enable reflection on that specific class at compile time. Okay, so we used this thing at the very beginning when we started playing with Graal. We used it to have this JSON descriptor, but now Drools is not using any reflection anymore. Okay, so we did this at the beginning, but now all the Drools code is reflection free, and this allowed us to do a nice cleanup of our code. I mean, this can be seen as limitation, especially if you do a framework or a toolkit, a complex tool like could be a rule engine. At the beginning, you see this thing as a limitation, but I think it gave me the opportunity to review my code and to understand that I was abusing these technologies, and there were a better way to do the same thing. So I took this as an opportunity to review my code and refactor it and clean it up. So yes, they are limitations, but they give you a chance to rethink about your code. And how we solved this problem? We created what is called this executable model, which is in reality the model, a complete Java-based representation model of a rule. Okay, so this has a lot of advantages for us. As I said, it provides a pure Java representation, and this allowed us also to improve the backward and forward compatibility, because what we did before was serializing the rule set definition, what we call the knowledge base, and you know that the Java serialization is quite weak, meaning that if you change just a little bit, it's very easy to break the compatibility. But now that we represent the rule with this intermediate pure Java way, we solve this problem. And this allowed us to fast prototyping new features, because we don't need anymore to create a new feature and then create a syntax for that feature inside that language and the parser of the feature. We just create the Java representation so we can test it in the engine, and then after that, when we are happy, we can add that feature to our Drools language. And except for this has been a prerequisite to make Drools and jBPM compatible to GraalVM and to allow us to create this native image with GraalVM. Okay, so how does this executable model looks like? It's a quite complex DSL, because it is representing all the feature of Drools. But you don't have to write it. You still use the rule language of Drools, and then we have this automatic code generation that creates this Java code for you. You even don't have to know that this code even exists. But with this code, we are replacing all the constraint evaluation with lambdas with Java predicate. So there is no reflection anymore. And the same thing is for the left and the right hand part. It's just another lambda that takes the matched object in the rule and with another lambda expression creates this the execution of the rule. And as you see, this Java representation is much more richer, but also more complex than the original representation, because we have to put inside this representation all the information that are implicit into the language, meaning how we want to index a specific constraint and other stuff that we need to make explicit in this model to allow Drools to work without reflection. Okay.
Yeah, and similar work was done around the processes. So we have the executable model for processes as well. So this transforms a process definition from BPMN2 into a Java format. So again, what Mario described is allowing us to run in the native image world. But at the same time, it removes the need to do the parsing of the XML, do the transformation, compilation, and so on at the runtime. So this is what was happening right now, but we can do and take advantage of the ahead-of-time compilation that applies to this part as well. So you can immediately get the process definition, transform it, and not only to transform it, but based on the information itself extracted from the process definition, we can generate a lot of additional stuff, like for instance, REST API based on the process definition, or the domain-specific data and the data model, all based on the process definition.
And yes, so at this point, I've been allowed to avoid this dynamic class loading. So now we have a different implementation of our internal class loading that doesn't do any class loading at all. And then we discovered, for instance, that we had the same problem even with the XML parsing, because guess what? When you parse an XML, you lose tons of reflection, and you don't want to do it. Okay, or you are not allowed to do it if you want to create a native image, or you have to put that the domain object that you want to unmarshal in that JSON descriptor, which is the thing that I did at the first stage, but we are not doing this anymore because we learned the lesson and figured out, okay, we can solve the problem with another small chunk of code generation. So at compile time, we parse the XML and we translate it into a Java representation of what is written in that XML configuration file. And we also solved this problem. And the other problem is that there was another thing in Drools that was breaking this closed world assumption, because Drools is a modular rule engine. You can add different module, and every module provide a different service to the engine. So it registers itself with a configuration file, and in this configuration file you have the class name of the implementation of a given service. Okay, and then this implementation was loaded at runtime. Still, this cannot work because it was breaking the closed world assumption. What we did in this case was pretty simple, because we needed to find a way to avoid breaking the closed world assumption. And the way we did this is that we put the name of that classes in another generated classes with this class for name with the name of the classes. And guess what? I'm not breaking anymore. Yes, notice that I'm doing a class for name there, but I'm not breaking anymore the Graal closed world assumption, because I'm giving to it a constant. Okay. I'm giving to it a constant, which is the name of the actual name of the class, and Graal knows at compile time what that class is. If I replace that constant with a variable as we had before, it doesn't work anymore. Okay, so this is another way, another trick that we use to make our stuff compatible with Graal. And I had, after all this work, I finally had a first version of Drools natively compilable on GraalVM. And yeah, this was nice. I was really happy. I remember it was the 25th of December, the Christmas day. So I sent an email to all my colleagues too much to say, finally, I have this. And I also posted the result, which was really impressive, because I have this small main class we called Drools by executing a few rules, and I compared the Java Virtual Machine version against the native version, and the Java Virtual Machine version took like 730 milliseconds to run this, while the Graal equivalent, the native equivalent, had a sub-millisecond execution time. And at the same time, the Java Virtual Machine version took 103 megs of memory, while the native version only 16. So at this point, I had the confirmation that my work was worthing the effort, and I was really happy with this result. And we continued with this proof of concept that now is become Kogito. And
right, so looking at the next steps, because that was the part that we made to actually run Drools and jBPM on Graal, and making sure that we have the ahead of time support for it, ahead of time compilation support for it. But that was not enough to actually make it usable. So to make sure that we wanted to make sure that we can actually expose this as a service, we wanted to add additional stuff, and this was the kind of a lucky time where Quarkus has been announced as well to run, because Quarkus is maybe a first question. Does anyone heard about Quarkus?
A few. Okay.
Okay, few. So that's another Red Hat project that is actually bringing in an ahead of time compilation concepts into enterprise applications. So it's relying on quite well-known Java-based specification and frameworks such as Hibernate or CDI, REST-easy, bringing in the JDBC and then the complete microprofile as well into the picture. So you can actually run everything out of this specification in both JVM mode and the GraalVM native mode. So that allows you to actually target not only the regular microservices workloads, but as well the serverless workloads, where you can actually build your application or your service to become a function as well. So it allows us to actually move forward and enable the process automation with features out of this ecosystem. So we can actually expose things such as processes or decision as a service through the REST API using JAX-RS, or maybe connecting to Kafka, or maybe connecting to AMQ with different protocols and so on and so forth, without much of an effort, and taking advantage of the ahead-of-time compilation, introspection of the business assets. We could actually generate majority of the things that you would need to actually expose this as a service.
Yeah, so just to be clear, with Quarkus you can optionally use GraalVM. You can optionally, you can run it as a normal Java service, as I will show in a minute, especially when you are under development, because to create a native image, it runs very fast, but to create it, to compile it, it can take a few minutes. So probably you don't want to create a new native image while every time you change something while you are developing. So again, with Quarkus you can optionally create a native image, but of course it also works in plain Java mode. And as much mentioned, you can use a lots of enterprise grade technology with Quarkus, and Quarkus will ensure that all this technology work well together and are compilable, and you can create a native image out of it. And the advantage of this are, as I said, you have a super fast startup time, you have a lower footprint, lower memory usage, and this is especially good for the serverless architecture. So if you have, the one thing that we want to enable is to use Drools and jBPM in a function as a service situation. So you have to evaluate a set of rules. You just put it into a function, into a lambda, and then when you have to invoke the service, you throw to the web service the object that has to be evaluated by the rule engine, and then you have a function, so it brings up the function, it evaluates it, and then it dies. Okay, so you have these super short living processes, which is really the situation where this native compilation shines. And indeed, together with a customer, we did some benchmark to understand the trade-off between the native compilation and the a native compiled program and a traditional hotspot program. So if you look at these lines, you see that, okay, this is on log scale, so the distance are quite big, even if you don't see it, but on a log scale, they are quite big. And so these are the performances, and this is the time, the lifetime of this application. So and this graph is very nice because really show how this stuff works. Meaning that the blue line is the natively compiled application, okay? And you see that it's pretty flat because the ahead of time optimization, all the optimization at compile time, and at that point you have something that performs well from the very beginning, okay? And conversely, on the other lines, you see the plain Java version. And of course, guess what? At some point, the just-in-time compiler performs better that ahead of time because it is taking statistics of your execution. So of course you can do optimization that the ahead of time compiler cannot do or cannot do yet. Okay. So at some point, the Java version start performing better than the native one because the just-in-time compiler can do better optimization. But what this customer was interested in is to have a flat execution time during the whole life cycle of this thing. So, and they really have these short-lived services. So they found that in this case, using the native image was really a game changer for them. And then,
so yeah, so this is what enables us to actually run on the native, but as well at the same time, using Quarkus enables us to take advantage of another quite useful, especially for developers, feature of Quarkus, which is a dev mode. A dev mode allows you to start the program once and then do the live reload of your code. That means that whenever you change your code, it will be live reloaded within the application without restarting it. And it does that rather fast, but at the same time, it's not only doing that for Java code, but as well for other type of resources. So this is what we've done for Kogito itself. So Quarkus allows to use different frameworks, and this is called an extension. So you need to build up an extension to actually fit into Quarkus ecosystem. And while we were evaluating Quarkus, we came up with that, yes, we kind of provide additional programming language to the Quarkus ecosystem because we have DRLs, which is a Drools rule language. We have the BPMN2, we have DMN and so forth. So that actually became a sort of a new programming language for Quarkus itself. Because it couldn't just figure out, okay, you have a DRL, which is a text file, or BPMN file, which is an XML file. How do I do a live reload of that? Yeah, you can change the text file, but I don't really care that because this is not code to me. So this is what we've done as part of the Kogito extension to make sure that we can actually plug into that live reload sections, but at the same time to make sure that we can simply generate the code as part of the Quarkus augmentation phase. So this is where you build your application. The Quarkus then jumps in, start doing the additional steps to make your application work within the Quarkus. So it can actually perform this ahead of time compilation, optimization, and so on to make sure that your application will simply run.
Okay. So this is the thing that is doing this ahead of time compilation, and we just in the Quarkus extension we already had in Drools and then jBPM, the thing doing this code generation. So it was, in this case, it was pretty simple for us to write a Quarkus extension because we just needed to wire what we had on the Drools and jBPM side. And then, yes, as mentioned and as much said, there's a second part of this extension, which is the actual part that does the auto reload. So what Quarkus does is that when you change a file, in their case, a Java file, they didn't recognize our DRL or BPMN file, so we send a few pull requests to the Quarkus team to enable also our use cases. But in general, what happens is that Quarkus figure out which rule is changed, so notifies with a callback your extension that one given file is changed or a set of files is changed, and then you do something. So what we do is just we, for that specific changed rule or process, we regenerate the part of the code that represent the rule of the process, and we reload inside the Quarkus class loader. So this is how we just implemented also the auto reload.
And just a word of explanation that when Mario said that it was a simple thing to write an extension, it is a perception right now.
Yeah.
But it wasn't at that time. When we submitted our pull request for Quarkus, I think we had 120 comments there.
Yeah, yeah.
So it wasn't that simple or that easy to pass it through.
Well, yes. So, when you do an achievement, then you forget the pain. Yes, this is a quite typical thing. Yeah, you're right. So yeah, we also wanted to demonstrate this reload thing. So I'm shutting down the servers running with the native image, and I'm bringing them up, but in dev mode. Okay.
It's exact same applications. It's
yes.
the same onboarding app, but running in the dev mode right now. So you will see that what it is composed of, and do a bit of hot reload or live reload of the decision-based services. Make sure that it reacts immediately without much of a change from a developer side. It starts a bit slower than the native mode, but it does the compilation and the augmentation phase right now while it starts.
So it is doing now what Graal did ahead of time. So this time is taking like 2.5 seconds to bring this service up. But the nice thing now is that it's running in pure Java mode, and you also have this auto reload feature. So we can give this a try. I can do the onboarding for another employee, and you will see that it will happen something similar as before. So I'm onboarding this new employee, and it has the same manager because in the same country, US. But we encoded this, in a rule. So we have a rule that say if yeah, sorry. Okay. Sorry. So yeah, we have a rule that assigns a department to the new employee based on his country, and then based on the department, he assigns also the manager to that employee. But I can now my services are still running, and I can change it this thing. So I can decide that from now on, there's a different manager for the employee enrolled in US. And then I can bring in a new employee. So let me change the ID. And you will see that now the new employee from the same country has been assigned to the new to a different manager, just because this is what's happening. The Quarkus notified my extension that the DRL has changed. I'm doing the hot reload of that DRL, meaning that I'm recreating the Java model of that DRL and loading it back into Quarkus. And everything works without shutting down and restarting the server. So this is one of the other big advantage of using Quarkus as framework. Okay, and I think we are done. So question? No question? Okay. How many people? So in reality, me for the Drools part, and then we were me and another person during alpha wave during this process. In reality, we have been lucky because when we starting this executable model thing, we didn't know anything about GraalVM. As I said, we did this for different reasons, because we wanted a faster startup of our stuff, so we don't want to parse every time the DRL from scratch, but we wanted a Java representation of it. So we did this thing like 1 year or 1.5 years ago. We didn't know anything about Graal when we started with this thing. That we start learning about Graal, and we figured out, oh look, we can use GraalVM with this stuff. And then we figured out that we can use GraalVM with the executable model thing. And I've been lucky for a second time, meaning that at that point, Red Hat was starting this new Quarkus initiative, which is based on GraalVM, and so we also started integrating it. So to be honest, I've been lucky twice, because I start doing something without being fully aware of the consequences, but it worked in the end. Okay, thank you.